Hi, everyone. Welcome back. We're going to continue talking about our Unit 10. And today, in our Day 3 notes, we're going to be talking about our applications of 3D geometry and finding things like volumes. Now, one thing that might come up today is the topic of density, which you remember for science class. And density, right, talking about how dense an object is a relationship between the mass and the volume of that substance. Okay, so something that might want to keep in mind. Okay, number one. So number one, I have an aluminum can. And my aluminum can has a height of 6 inches and a diameter of 2 inches. And I want to know how many cubic of inches of soda are in there. So it's asking, what's the volume? So the volume, remember we have big B times H for the volume of any one of our prisms. And what we want to talk about now is the fact that it's a circle. So pi r squared times the height. So pi, now if our diameter is 2, then our radius is 1. So 1 squared times 6. So 6 pi. And I put that into my calculator. And I get about 18.8 cubic inches of soda. All right, number 2. So we have pine bark, and we want to mulch this 6 inches deep, and we're going to spread this around in each of the flower beds. But mulch is only sold by the cubic yard. So I want to know how much mulch will need to be purchased. Now I want to also notice that these measurements here are all in feet. So we have feet, we have inches, we have yards. Let's convert everything to yards. Now, it's not the only way to do the problem, but it will make it pretty easy. Okay? So if I look at 2 feet, that's really 2/3 of a yard. And 25 feet is really going to be 25 thirds. We'd have 4 thirds, 25 thirds. And here, if my radius is 7.5, then my radius then will be 7.5 cubed, right? And that takes all of that and turns all of those into yards. All right, so let's find the volume of our rectangular prisms first. So length times width times height. So we've got 2/3 times our 25 thirds and our 6 inches deep. And again, not to make this too complicated, 0.6. Whoops, sorry about that. Not to make it too complicated, but it's a half a foot, right? This is going to be 0.5, right? So it's a half a foot, right? So it should be 0.6, 0.5 thirds. All right, so I'm going to plug that into my calculator, and I get 25 over 27 yards cubed. All right, and remember that there's 2 of those. All right, let's find the volume of this one down here. So volume, we'd have 4 thirds times 25 thirds times that half a foot, third of that, right? So putting that to my calculator, 50 over 27. And so that's right here. All right, so now for my circle, we've got the volume equals pi r squared h. So pi, now my radius, 7.5 thirds squared. Multiply that by height. Oh, my height is, remember, my half a foot. And again, we're doing this in yards. All right, so now I'm going to put that into my calculator. I end up with 25 over 24 pi yards cubed. All right, so now in my calculator, all right, I'm going to add all those together. So we had 25 over 27. We had another 25 over 27. We had that bigger garden, 50 over 27. And then we have our 25/24 pi. Okay, we're going to add all those together. And we get about 6.97. So that's going to tell us we need about 7 cubic yards of mulch. All right, number 3. We've got 2 tennis balls, each with a radius of 12 centimeters. They fit exactly in the 48 centimeter tall cylindrical can. I want to know the exact volume of the air in the can. All right, so think about the air is going to be all the leftover space. So the first thing we're going to do is we're going to find the volume of the cylinder. All right, so for volume of our cylinder, we've got pi r squared, because we have a circular base, times the height. So my volume of a cylinder, pi, my radius we know is 12, and my height was 48. Okay, so we have 12 squared times 48, 6,912 pi, and it's going to be centimeters cubed. All right, now let's talk about the tennis balls. All right, so the volume of my tennis balls, the volume of my spheres, 4/3 pi r cubed. So 4/3 pi, and the radius there was 12 cubed. All right, so we've got 4/3 times 12 cubed. So 2,304 pi, and again, centimeters cubed. So now, if I want the volume of the air, I'm going to take my volume of the whole can, take away my 2 tennis balls, so the volume of my cylinder minus my 2 tennis balls. Oh, shoot, it said exact volume, silly me. So if it wants exact volume, I got to take out the pi's. Oh, silly me. So take out those pi's. There we go. And I get 2,304. So this is 2,304 pi centimeters cubed. All right, question 4. The table shows the approximate measurements of the Great Pyramid of Giza in Egypt and the Pyramid of Kukulcan in Mexico. So I want to know what is the difference between the volume of the Great Pyramid and the Pyramid of Kukulcan. All right, so volume for a pyramid. So volume equals the big B times the H. Now notice that it just gives us the area of the base. Oh, sorry, pyramids, 1/3. All right, so let's try our first one. Okay, so the Pyramid of Giza. All right, so my 1/3 times the 52,900. Again, they're both in meters. That's good. Times 147. Okay, volume of that gives me 2,592,100 meters cubed. Now the volume for the other pyramid, 1/3 times the 3,025 times 30. And that's going to give me 30,250 meters cubed. I want the difference. I want to subtract those. So I'm going to get right there, letter B. All right, stay tuned for more.